Do you want to add some flexibility to your Raspberry Pis? Do you have other devices to power and are tired of using wall warts power supplies? Well, stay tuned and I'm going to show you how to do this. Welcome to another edition of Tech Bites with Ron Nutter, your home for all things relating to smart home technology. In this episode, we're going to talk about implementing a scalable power solution for your Raspberry Pis and other devices. Hi, I'm Ron Nutter and we're going to be working on this together. This content is also available as an Amazon Flash Briefing or podcast. Please go to techbiteswithronnutter.com for more information. For any items mentioned in this episode, there are affiliate links available in the description. If you click on these links, I will get a small commission, but that won't affect the price you pay for the item. If you haven't already subscribed to the channel, please click on subscribe now and enable notifications. If this video helps you or provides value, please click on that like button, thumbs up. Well, now here's what we're going to be talking about this time. Building a scalable power solution. This is going to be something that is going to be a big help. The idea behind this one, you saw my earlier video in this series to where I kind of got caught with a bunch of wall warts or power supplies and it just became very unscalable. So I wanted to find something that I was going to be able to move forward with. We're going to go over the required items list and then showing you how to get everything connected just in case you haven't done this, and then how to power profile the new devices. What we ended up going to was a bench power supply. Now, for those of you that have a ham radio background or know somebody who is a ham radio operator, they know all about this kind of thing. Although typically theirs are 12 volts of some amperage, 20 amps, 30 amps. This one can go to 32 volts and can go up to 10 amps. I tried finding one larger, but that's when it started getting into a little more money than I wanted to spend at this point. And that can very well change. Now, what I've done at this point is the HM310, that stands for 32 volts or 30 volts, depending. Technically, it's 30 volts at 10 amps. Now, you dial up the voltage, and then I locked it in at 5 volts. And I initially set the current lock at 3.5 amps. I don't want it overfeeding that at this point. You got to set a limit somewhere. Now, the output button does let me disconnect it from the Raspberry Pi. So if I have to pull something upstream of the power distribution system that I put in place, this gives me an option. This is going to be the piece that's going to let me really feed multiple Raspberry Pis. What I've had to go do is I basically made some custom cables using a kit of ends that lets me tie in to the power supply, then to the distribution terminals you see with the lines going to it, plus and minus, and those would match the ones on the power supply. Now, in terms of the fuses, I'm going to have to order some fuses that are more in line with what I want to do. The lowest amperage that came with it was 5 amp. That's fine for probably an automotive situation, but with the Raspberry Pis, I want the ceiling a little lower than that. And my choices are 3 amps and 5 amps. 3 amps is cutting it a little too tight because especially if you've got several devices plugged into the Raspberry Pi that it's powering, you're probably going to be pulling close to 3 amps, or if it's running a lot of heavy computational processes or jobs, however you want to call it, then it's going to be pulling a little bit more. So certainly 5 amps is better than not being able to hit it at 4. 4 amps is better to be able to hit it than trying to put it at 3. I tried finding a 3.5 amp fuse. They're simply not to be had, at least not with the searching that I did. And then each Raspberry Pi is going to tie in individually. There's a common negative bus bar where you see those 3 screws together with a little metal plate under them. That's a common negative bus. So all the Raspberry Pis tie into that on for their negative line, then each one will tie to an individual fused entry. And you'll see this more here when we switch over to our trusty demo cam, which let's just go ahead and do that now. The power supply, and unfortunately I can't back off the camera anymore because I've got it about as high up as I can take it. I've got cables that I made with the crimp on ends, going to be how I'm connecting to the fuse block, and I've got it preset for 5 volts, 3.5 amps. No, if I want to take the 3.5 amps above that, then I just push the current lock button until I get to where I'm wanting to adjust, and then move off and it will go ahead and lock in that setting. Same thing for voltage. I mean, I can go up to 5.1, and if I let it set, then it will go ahead and lock it down, ready to go. See, at this point it says off. So it says the output button right here has to be pressed in order to turn it on. Here's what I've gone and done in terms of wiring. And let me get this down here a little bit more so you can see it. Push this off here just a tad. This is coming off the negative pole on the power supply that you saw, and then this is coming off the positive terminal. When I first connect something in, I won't put a fuse in just to protect things from possibly having a problem. Then the negative terminal, like I said, for the cable is going to come right into here. It doesn't matter which one you use. This one, it does matter because if you're going to hook something up here, then there has to be a fuse in here. And right now, I've just been leaving this cover on here. I'm not locking it in the way you could. I'm going to show you something with the power cable. Hopefully the camera will cooperate with me here. I've actually taken and cut off or cut in halfway into the cable on one of the CanaKit power supplies. I tried finding just the USB-C ends going to bare wires. Thought I was going to be asking for the keys to Fort Knox. Simply, I couldn't find them, and the ones I could find, I couldn't tell anything about. Was there any sort of what kind of wire I was putting into the connector? And this way, this one's rated at 3.5 amp. The wire here is going to be fine. Now you notice I've got some heat shrink tubing. More of that in just a moment. So what you'll have to do, and this is going to be a manual process, because until you can find a cable that's going to play a little bit nicer, I'll cut in and very carefully with a good sharp pocket knife, I'll cut off the insulation, and you'll probably have to, from where you actually cut the cable in half, you'll maybe have to take it about an inch or so at a time, or using a pocket knife, just pull it back and just slowly shave it. Be very careful, because that blade sharp, one slip and you're going to cut yourself. So just be careful. You can do this, but just be careful. Then once you do that, and you'll have to take this outer jacket away in sections, and then what you will probably run into is you'll notice there's a little bit of bare metal here. Well, that's exposed wiring, and I don't like to have that one, just for a variety of reasons. So that's where I got some heat shrink tubing, and I'll put that over each section, and the heat shrink gun is going to be here hopefully today. So I'll put these in place. Now, since the kit of heat shrink tube I got did not have red, at least in the size that I needed to have it, I put the black they did have over this, and then since the other cable in the CanaKit power supply is coated red, then I put clear heat shrink on it. That will let me make sure that I still see it as the positive cable. Now, the crimp-on connectors, you want to put in you want to shave away about 1/8 of an inch, maybe, off the end. And when you go to pull it away, and I'll have linked to a good set of wire strippers, you don't want to see any wiring coming out when you pull off the insulation off that inner wire. So that's going to be something, it's going to be an acquired skill. If you've not done this before, or have not done any of this, any or a lot, you can do this. Just take your time. Now, once you have done that, you'll want to securely crimp the connector. And unfortunately, that's about as close as I can get it focus on it. You'll see it's flat all the way through. There's a crimping tool that I did get a hold of that it seems like overkill, but trust me, it's good and flat. While you could do this with a pair of pliers, this one will exert a whole lot more force, and especially if you're doing quite a few of these, at the end of the day, it's going to be a lot less tiring in your hand muscles to get this done. Once you have that in place, then the first thing I do is I'll hook up the two ends here. I've just turned on the power supply. I'll back up here a little bit. So without a fuse in place, this light comes on because it thinks the fuse here is blown. Now, when I first go to hook this up, I don't have a fuse in place, because at that point, I'll have the power supply turned off. This is only with the first one. From the ones moving forward, obviously, I'll hook this up, then put the fuse in. So we've got everything all there. You can see that that's the negative line. So it's going to this negative bus bar up here. And then the red, which is the positive voltage, is going to go back into the cable and plugs in here. Now, eventually, I will put an on-off switch in there, but for right now, with just the one, I just didn't do it. We'll go ahead and turn the power supply back on. You can see that it thinks it has a blown fuse. It really doesn't, but once we plug the fuse in, light goes off and the Raspberry Pi starts to boot up. This is where you'll look at the front part of the display. This is where it's showing you the amount of amperage it's actually pulling. So at this point, it's locked into feeding only 5 volts, and it's showing you it's taking it runs about 0.6, 0.7 amps, which for nothing else in there is about where I would expect to find it. And then for those of you who want to deal with things in watts, it's got that on the lowest part of the display. It's always good to profile the devices when you first go to plug them in. For the first device, you can use the front part of the display on the power supply. That is going to be what it takes to show you the actual amperage that it's pulling, which in this case is pulling about somewhere between 0.7 to 0.8 amps, sometimes a little bit more depending on, in this case, I've got an aircraft data receiver USB stick plugged into it, so it's going to vary a little bit in size. It's always a good idea to profile any new Raspberry Pi, or if it's anything else you're tying into with the 5-volt setup here, it's always a good idea to know how much power it's pulling, because at this point, as you saw earlier, I am locking the power supply to not going over a certain amperage. So that way it doesn't try to overdrive the supply. And I'm just trying to head off some problems at the pass. Now what we'll do is I'm going to show you how to do this with your digital meter. You've seen what it takes to do the power profiling or finding how much power it's pulling from the power supply if you got a single item. But when you've got multiples, it may not always be practical to shut everything down. So what we will do is we'll go over here to trusty demo cam, and I've already got my voltmeter set up on amps. Okay, now we're going to put the fuse. I need to leave the fuse in. I'm going to put the negative probe at that terminal, and then I will hold it other one on here and then make sure it's set on DC volt. So this is pretty much keeping in line with what the bench power supply is showing. So just to recap things, I've got the negative probe downstream of the fuse, so it's picking up the power, and then I've got the positive probe feeding the Raspberry Pi. And at this point where I'm watching both the meter and the output of the power supply, they're pretty much in lockstep with each other. So that gives you a good indication that the power supply is reading correctly. So I've shown you two different ways to power profile the Raspberry Pi or whatever device you're tying in. This is important because with the bench power supply only being capable of 10 amps, we want to make sure that we don't overload it. And rule of thumb I'm going with is I'm trying not to take it over about 70 to 75%, just in case one of the other Raspberry Pis would spike, that I've got a little bit of capacity left before it goes into a condition where the power supply might shut down, or maybe there might be damage to one or more of the Raspberry Pis. Based on the projections I'm seeing, assuming that the Raspberry Pis will be pulling on average of about 8 to 900 milliamps, I will be able to drive probably between 8 to 12. 12 will be the absolute top end. 8's probably a little more realistic. And where this becomes important is I'm looking at another video project involving the Raspberry Pis where I'm going to have multiple running at the same time. So I've got to make sure I'm not going to overload the power supply. And those will probably be pulling a lot more power. And when you see that series, when it comes out, which is probably a few weeks out, you'll see why it's important to profile the device and periodically just go in and check it to make sure that it is still pulling what you think it is, because it's going to be good to know what the Raspberry Pis will require on an individual and a composite basis. But once you get this up and running, really to an extent should take care of itself. If you're watching this on YouTube, you're going to see videos on the screen that are similar to the one you've just watched or other content that YouTube thinks you might be interested in. If this video helps you or provides value, please click on that like button, thumbs up. If you haven't already subscribed to the channel, please click on subscribe now and enable notifications. We'll see you in the next episode. Thanks for watching.